All right, Assalamualaikum, good evening. Okay, what I'm doing tonight is 30 years anniversary of this first publication, my first scientific breakthrough. Yeah, so I would like to bring you back to the year 1994. I was a very young and probably innocent PhD student in the University of Nottingham. I was standing in the lab, frustrated because those days the problem was that we thought that it is not possible to make gel, very good gel, using very low protein concentration. So you need a lot of protein in order to make gels. So that was my task. That was my job. I was given bovine serum albumin as the samples, as the model of the study. Let's just call it BSA. And according to knowledge those days, you need at least 9% concentration of BSA in order to produce a gel. At 3% or lower, nothing will happen. Yeah, it will stay as liquid. How much heat you apply, you will never get any gel. That's the law. Okay, so my job is to prove that it is possible to make gel at 3% or lower. Okay, so my supervisor, Sandra Hill, Dr. Sandra Hill, Professor Sandra Hill now, they were playing with reducing sugars, yeah, ribose, xylose, very strong reducing sugar. For us, we are familiar with glucose or lactose, also reducing sugars. So they have added things like xylose, 3% xylose, in the presence of maybe 1% or 3% BSA in retorted system in canned food, and it will, of course. So my job is to study the kinetics at a much lower temperature, about 90 degrees C, typical heating at home, or probably in the pasteurization range. Yeah. So this is what I did, and this is what we found. Yeah. When reducing sugar, ribose or xylose added into 3% BSA, boom, it gel. Yeah. The story, there are a lot more story there. It's not straightforward because the rheometer that I use, even though it's written there, operating at, we needed this 90 degrees C, but this particular rheometer actually register uh, 5 degrees C lower. So nobody could find out how to solve the problem. They thought 90 degrees C means 90 degrees C. So I came and I measured the temperature, and I found out that even though it stated 90 degrees C, it is actually 85. So the kinetic is not enough. You need 5 degrees C higher temperature. So I set the rheometer at 95 degrees C, and the actual temperature in the rheometer cell is actually 90 degrees C. So that's why the gelation of BSA at 3% occur when ribose or xylose was added. Yeah. So this is the first publication. Okay, I'm sure you're not interested in the details. Okay, we measure. I was the first to measure this. That is called the gelation time. You see, this is what we call G prime, the solidity. Storage modulus actually. Okay, imagine this is liquid. After a certain time, the temperature here I claim as 90 degrees C, but I set actually at 95 in the rheometer. Okay, and then zoom, it become more solid. So that is the gelation time here. The gelation time when the liquid turn into solid gel. Yeah. So now you know the gelation time. You can actually measure a lot of kinetics. It is a breakthrough. Yeah. You do different reducing sugar here, xylose, and then ribose. Okay, you see here, the higher the reducing sugar, the shorter the gelation time. See, that is the major breakthrough. Nobody knows about it. Okay, okay. It's not just discovering that. So as scientists, we need to know what happened, why it happened that way, the mechanism. Yeah, maybe it is just drop in pH. You see here, this is pH. As you can see, it's small. As the time in water bath, the longer you left the solution in the water bath, even the gel, the pH will drop. Yeah. So maybe it is just the pH causing the gel to form. Okay. Of course, we were not very satisfied with this explanation or hypothesis. So we dug deeper, and what we found out is very interesting. Actually, because the Maillard reaction between reducing sugar and protein, there is a loss of the basics, the lysine, basic amino groups that causing these charge alterations that allow the protein to come closer together, but instead of coming together in a very accidental way, boom, like a blobbing thing, but they come slower. The pH drop, they're supposed to come very rapidly, come together like that, but because of the charge, they come at a very control rate. Yeah. So because of this control rate, the network in the gel was stronger and higher quality. I have another paper that to prove that. Yeah. Especially with the stronger reducing sugar ribose, we can detect some formation of well, I want to claim we have proven this, but covalent cross-linking. Yeah. Okay, so this is what interesting here, the pH at the gel point. Yeah. If it is gelation is due to pH alone, yeah, so the pH at gel point should be like this, just same. Yeah. It is independent of reducing sugar concentration, but uh, because the increase in reducing sugar and causing a different drop in the pH of the gel point, that means there is a very strong impact of the charge alteration plate on the gelation of the 3% BSA. Okay, it was not just pH then, it was the chemistry of Maillard reaction with protein. Yeah. So this discovery proved something radical actually at the 1994, 1995, that you didn't need high protein level to make gel. That's one. And then you can use this chemistry or the Maillard reaction to unlock new textures and functionalities in food. I did a lot of gel work after that, and then protein packaging. Okay, there is many low protein formulation, functional food, even dairy and meat analogs. So I started my work in Nottingham in 1994. Yes. Then this paper published in 1996. Yeah. My first publication. So today, 2025. So it is like well, 30 years ago almost. Okay. It is very big for me because it was my first publication. Yeah. So today, almost 30 years, young student, very naughty student, 1994, 95. I really enjoyed staying late in the lab. Our lab in Nottingham closed around 12. Yes, 12 midnight. So me and my friend hanging around there every 1 or 2 hours. I went to the lab and changed sample in the rheometer until I can see all kind of results. Yeah. So, can a little protein ever gel? That was the answer. The answer is yes, if you give it the right sugar and a little heat. Sometimes science progresses not by proving what we already know, but by daring to show that the impossible is actually possible. Okay, that was my sharing tonight. My first publication in 1996. There was no internet, yeah, those days. So we submitted the papers in 1995, early 1995. Wait for 1 year, then only there is a process of normal process of sending letters and then sending a review 3 months, 3 months, 3 months. After 1 year and more, then it got published. Yeah. Thank you for listening, guys, for almost 10 minutes. So that's my story. Bye.